All right, class, welcome to lesson 3, which is Introduction to Slope. So remember how in today's class I said that I'm going to show you an easier way to find that equation? That's what this is going to be. So what we're going to be talking about today is slope, and it is the measurement of how steep a line is, or in more technical terms, we say it is the rate of change. So how fast or slow something is growing. The slope of the line or the line segment is found by finding the rise, so how much is increasing or decreasing over the y-axis, and the run, right? So how much is increasing or decreasing on the x-axis. What we're really doing is we're going to go back and we're going to be working with our coordinated pairs x and y. How we like to write slope is we like to write it as rise over run, which basically means the change or delta y and the change in x. This is why it's called rate of change. Cool. So if we're going to calculate slope for the following segments, let's do that. So I'm going to start off with the rise. The rise is how much it's increasing or decreasing in the y-axis. So if I'm just going to go here, I'm going to draw just over to the side my little Cartesian plane. That's my y, that's my x. So if I want to know how much it's rising in my y-axis, what I'm going to look for it is how much is it going up or down, right? So I'm just going to go over here and I'm going to draw a little highlight here, right? In that situation, my rise is 16. Now I want to know how much my run is. My run is going to be the change in x, which would be here, right? So my slope is going to be, I'm just going to go back here and look at its rise over run. So it's going to be rise over run, and my rise is 16 over 8. I'm just going to do 16 divided by 8, so my slope is 2. So try doing this one by yourself. So I'm going to just draw in my little Cartesian plane actually just in here so that you guys have something to compare it to. So I won't even draw it over there, I'll just draw it in over here. So that is my, let's pretend that this is like this. That's my y, that's my x. So go try it by yourself, and then when you come back, you can check this out. Okay, so welcome back. I'm going to assume that you would try that by yourself. So my rise here is going to be the change along the y-axis, which is 20. My x here is going to be along the run is going to be along the x-axis. So think about it. It's like you're running. When you run, you're running in a straight line across horizontally. When you're rising or when you're climbing something, you're going upwards, right? So you're in an upwards motion, so you're y. So my run is going to be 6, and I'm going up by 20. So over 6, up 20, right? And so my rise is going to be rise. My slope is going to be rise over run, which is going to give me 20 over 6. And I can always decrease that, and I'm going to do good form for this one. 20 over 6 equals, I can divide these both by 2, so that gives me 10 over 3. So my slope, or m, is equal to that. So I'm just going to change this back to slope so it doesn't confuse you. Okay? So that is how you find the slope. That's how you find that first relation, right? What we're going to be doing now is we're going to be talking about what a positive versus a negative slope is, right? So when you're given slopes, they're either positive or they're negative. Positive slopes go up and to the right. That's how they grow. They grow upwards. What a positive slope basically indicates, it means that an increase in x leads to an increase in y. They are directly proportional to each other, right? So if I increase the x value, I'm going to increase the y value, right? So say I have 1, 1, it'll look something like this. So the slope will be going upwards. And of course, you are going to have better slopes than me. Your slope could even look like this, could be less steep, could be super steep, But you see that they're all growing generally. When you have a low x, you'll have a low y. When you have a high x, you'll have a high y, right? So they're directly proportional to each other. Now, when you have a negative slope, the slope points downwards. Which means that an increase in x leads to a decrease in y. So as I make the x values larger, the y values get slower, right? So if I go from 0 to 1 to 2 to 3, the y values get significantly lower, right? They start to become negatives. Same thing over here. If I have something starting here, let's make it a little steeper of a line, right? Notice how at a high x value, or at a low x value, because it's on the left side of 0, I have a high y value. And at a higher x value, I have a lower y value. That's important to remember. I'm just going to draw this back in. So what we're going to do now is we're going to determine the slopes of the lines on the graph, right? So I'm going to use green to do line 1, and I'm going to use, let me find another color. Maybe I'll use blue to do line 2. Or actually we'll do pink. Pink to do line 2. Okay? So let's just do line 1. Line 1 is right here. I'm just going to draw it in, right? And I'm going to go find the 2 points. I have this point right here, and I have this point right here. I'm just going to erase this so that I can see what the point says. So I'm going to draw out my run, and I'm going to draw out my rise. How am I going to find that? I'm just going to count. I'm going from -1 to 3. So I'm going over 1, 2, 3, 4, 5. 5 points. So that's 5. And then I'm going up 1, 2, 3, up 3 points. Right? So I'm just going to count. How many am I going to the left? I'm going 5 points to the left and 3 points upwards. So my slope, so my rise is going to be how many am I going up? 3. Run was I went over 5. My slope is going to be rise over run, 3 divided by 5. Sorry, I'm just going to go back and write this as slope. Getting ahead of myself there. Okay, so let's try it with the purple or the pink. I'm just going to go in and change the color. So now I'm going downwards. If I'm going downwards, I'm going to know immediately that my slope is negative. Okay, because it's going downwards. This is positive because it was going upwards. Okay, so I know it's going to be negative. That's just something to keep in mind for myself. And I'm going to draw on my triangle. So I got this right here. Got it right here, right? And then I'm going to go right here. So let's do the counting. So I'm going from 1, 2, 3, 4, 5. I'm going down 5, so that's going to be -5 because I'm going down. And I'm going to the right, right? I'm going to the right, which is still a positive. I'm going to the right, 1, 2, 3, 4, 5. I'm going to the right +5. So my rise is actually a negative number, so it's -5. And my run is still positive, so I'm going to leave it as +5. So my slope will be rise over run, which will give me rise is -5 over +5. 5 divided by 5 is just 1. Negative divided by a positive is a negative. So I know my slope is -1. Moving on to example 3. And again, you can pause this, go over it whenever you feel like you need to review something. I highly, highly recommend that. I'm just going through this so that you can go back and watch this after. So it says calculate the slope, right? So if I know I'm looking for slope, I know I'm looking for a rise, and I know I'm looking for a run, right? It says calculate the slope of the line. And then the second question it's asking us is actually more important. What does that mean? I don't care if you can calculate the slope if you don't know what it means, right? So let's go over that. So let's find the rise over run. How you're going to find over the rise over run for something like this is I always like to pick 2 points. So you can pick these 2 points right here, right? You could also theoretically pick 2 points here. You could pick this point and this point right here. You could pick any point on the graph and you will get the same thing. And I'll show you that. But for our purposes, we'll pick the 2 last points because they're just the easiest, right? So I'm going to go here and I'm going to say, all right, this point over here is 320 y. And this point over here, and it's at 4. So x is 4, right? Y is 320. And this is just 0, 0. And I always like working with 0, 0 because it's an easy number to work with. So if I'm going from 0, let's count over how many points. I have 1, 2, 3, 4. I moved over 4 points. So my run is going to be 4. This is where this gets tricky, so pay attention. How many am I moving up? 1, 2, 3, 4, 5, 6, 7, 8. Is my rise 8? No, because each of these 8s represents 40, right? So what my rise actually is this number right here. You went from 0 to 320. So my rise is 320. Right? So you want to take how much did you actually go from here to here? So you always read where it is on the line. That's why I wrote those coordinates down. So now my slope is equal to rise, which is 320, over run, which is 4. So I'm just going to put that in. What's 320 divided by 4? Right? So 320 divided by 4 gives me 80. So that means my slope is 80. Now that I know what my slope is, right? My next thing that I'm trying to figure out is, yeah, I know what the slope is, I know what the steepness is, but what does that actually mean? So what's the meaning of slope in this situation? So how I always like to write this is I like to look at the units. So what are the units of the y-axis? km. What are the units of the x-axis? Hours. So what our formula is saying is that it's rise over run, or y over x, right? Change in y, change in x. So what it's saying is km over hours. Where have you seen kilometers per hour in your life? Speed. So therefore, the slope in this situation represents the speed of this vehicle. Right? Which is what it's saying. It just shows how far he drove in 4 hours, right? And it's showing us what the speed of that vehicle was. He was driving at 80 kilometers per hour. Okay? So moving on. A seagull is flying at the altitude of 300 meters, sees a piece of a hamburger bun on the ground. The graph shows the relationship between the average altitude, so how high up it is, and the time for which it descends to the ground. Right? What you want to find is the average change in altitude. So this is probably when he hits the ground, right? and he picks up that burger bun, and this is where he started. So he started off 300 meters high. We're going to just calculate the rate of change. So he started off at 0, 300, and he ended up at 10 and 0 height. So let's calculate the rise. So he went from 300 all the way down to 0. So what would the rise be? Rise is equal to 300. The run, he went from 0 seconds all the way down to 10 seconds. So the run is 10 seconds. So if I want to find the slope, is equal to rise for a run is equal to 300 over 10. And if I had enough space, I would write it in a separate line, but I don't. So I'm just going to write it in like that. So I'm going to do 300 divided by 10, right, is just 30. And if I go in and I write my units in, which I always recommend doing, I have meters per second, right? So in this situation, because it's meters per second, you're checking how fast did he get from the top to the bottom, right? So the speed at which the seagull ascended or descended, right? Because he's going down. Or if you said the rate at which the seagull dived, you said at the speed at which the eagle got to the burger, either one works. Okay, and then this is our last example, and you guys can go. So the graph shows that the volume of gasoline in a car tank is as follows. So it starts off here, and it declines here. Whoops, the one thing I forgot to say is this has to be a negative, right? The slope has to be a negative, so it's negative 30 meters per second. So we know that the speed at which he ascends is negative 30 meters per second. Okay? And yes, you can have a negative, it's not speed, it's like displacement, and you'll learn about that in physics. I'm not going to worry about it now. You just need to know that a negative speed represents that you're going down. Okay? So the graph shows that the volume of gasoline in a car's tank. So this is the volume of gasoline. Right off the bat, it's going down, so we know this is a negative slope, right? So we just got to make sure that our slope means that. So I'm going to go down and I'm going to find my rise over run. So I'm going to go in and draw out my little triangle. So I'm going from 10 here up to 70. How can I find out what my rise is? I'm going to go 10, 20, 30, 40, 50, 60, or I could have just done 70 minus 10, either one. So I know my rise is negative 60 because it's going down, right? It's going 1, 2, 3, 4, 5, 6, going down 60. What's my run? I'm going to go over. The one thing to notice here is you're going up by 60 each time, right? So I'm going 60, 120, 180, 240, 300, 360, 420, 480, 540, 600, 680, 720. So I'm going over 720. So my rise is going to be negative 60. My run is going to be 720. That means my slope is going to be rise over run equals negative 60 over 720. I'm just going to plug that into my calculators. Negative 60 divided by 720 is going to give me a decimal number, or I can just go and I'm going to actually find the lowest common denominator here. So I'm going to divide by 10. It'll give me 60 over 72. And I feel like I can reduce that even more. 72 divided by 3 is just 24. And then I'm left with 6 divided by 3 is 3. So I'm left with 3 over 24. Okay? And that's what my slope is. If you wanted to, you're more than welcome to put this in when I ask you to put this into, and it has to be negative, don't forget the negative. When I ask you to put this into, like if I'm asking you to solve a question, right? What you could do, oh, sorry, this should be 2. This is why we don't rush through these things. And I can actually reduce that even more. I can do 1 over 12, negative 1 over 12. Okay, sorry about that. It's a little messy, right? So if I want to interpret the slope as a rate of change, right? I'm seeing how much, what am I trying to determine here? What I'm measuring is how much volume am I losing the more I drive, right? So how I could say this is the amount of gasoline used per kilometer is 1 over 12. And you wouldn't write the negative 1 over 12, it just indicates the slope, is 1 over 12, or what makes more sense is 1 divided by 12, or 0.083 liters per kilometer, right? Because you have, it's 1 liter over 12 kilometers. And that tells you how much gasoline you're using. Okay, so hopefully this helps. This is tomorrow's lesson. If you're previewing this, awesome. So I'll see you tomorrow. If you're watching this after class, even also awesome. And we'll see you tomorrow as well. All right, bye.